Calcium hydroxide is almost insoluble in water, but it reacts with dilute hydrochloric acid. A student adds 100 centimetres cubed of 0.1 mole per decimetre cubed hydrochloric acid to 0.6 grams of solid calcium hydroxide. Show by calculation that the calcium hydroxide is in excess. So we need to work out the moles of each. So we're going to add up the MR of calcium hydroxide, so 40.1 for calcium and 17 twice for the hydroxides, so 74.1, 0.6 grams. And that on my calculator, so 0.6 grams over 74, 0.00810. The number of moles of hydrochloric acid that we've been given is 100 centimetres cubed times 10 to the minus 3 to get it into decimetres cubed times 0.1, which is 0.01 moles. Now, it tells us the calcium hydroxide is in excess, but it looks like a smaller number, but that's because the ratio is 1 to 2. Okay, so let's do it this way. The amount of calcium hydroxide needed to react with 0.01 moles HCl. So the number of moles of calcium hydroxide needed equals 0.01. Ratio is 1 to 2, so divide by 2, so that's 0.005. And then it's clear that 0.00810 is greater than 0.005, and so it's in excess. You need to be careful that you don't do things like this in an exam. That doesn't explain anything, and also it doesn't make sense. The number of moles of HCl is not 0.005. So just be careful that you are clear about what it is that you're saying, and write down some explanation. The final mixture contained a saturated solution of calcium hydroxide at 293 K. The solubility is 0.4 grams per decimetre cubed, and Kw is 6.8 times 10 to the minus 15 moles squared dm minus 6. So what does 0.4, because remember that to use Kw is concentration of hydrogen ions times concentration of hydroxide ions. That needs to be in moles per decimetre cubed, and this is in grams per decimetre cubed. So if we want to find the concentration in moles per decimetre cubed of calcium hydroxide, we need to get rid of the grams per decimetre cubed, and the way to do that is to divide by the MR, because if you divide by the MR, grams will become moles. So you want to do 0.4 divided by 74.1, 5.398 times 10 to the minus 3 moles per decimetre cubed, but that's for calcium hydroxide, and every calcium hydroxide in solution provides 1 calcium ion and 2 hydroxide ions. So the concentration of OH minus is 2 times this number, not 0.0107, round that up because it's 79, so 0.0108 moles per decimetre cubed. And then we can use Kw to get H plus. So H plus is Kw over OH minus. So 6.80 times 10 to the minus 15 divided by 0.0108. So again, on our calculator, I'm going to use that fraction button, put my answer into the bottom line. I'm getting 6.30 times 10 to the minus 13 moles per decimeter cubed. And then pH is the negative logarithm to the base 10 of the hydrogen ion concentration. So I'm going to do the negative logarithm to the base 10 of my answer, and that's coming out at 12.2. It says give it to 2 dp. It's coming out as 12.200, so 12.20.